Okay, question 8. We've got a question about circuits. We've got two different types of the same component. So we can see here is a dial that we turn around. This is on the front of those orange or blue lab packs. So we know that this is a variable resistor. And this one here is called a rheostat. And it is a variable resistor. And you will use this. We know we can push that along. And then if we increase the length of wire, we increase the resistance. And that's how that works in terms of varying the resistance. We can either have less or more wire in the gap. So name what it is. It is a variable resistor. The one from the front of the lab packs that we use, and the other one that you did use for your voltage current graphs a long time ago. Which row in the table describes the way that ammeters and voltmeters work? So we know ammeters go into the circuit. So let's draw a little circuit there. And we know if that was a bulb, voltmeters go around. They're connected in parallel. So we're after an ammeter in series, a voltmeter in parallel, and that's C. We've got some results here, and we've got current in milliamps. And again, if we need to do a calculation, that's going to have to be divided by 1,000, which I believe we do need to do in a bit. And it says, describe the relationship in the graph. Now, everybody on their mock got the first mark, and so many lost the second mark, and it's the easier one. So we can see as voltage increases, current increases. As that goes up, no problem. But then you've got to state, is it a linear relationship or a non-linear? Well, this is a curve, so it's a non-linear relationship. Or you could put words like it's increasing at a decreasing rate. The next one, use the values to find out point P and point Q. So we'd find that the voltage there is 1, and that's 20 milliamps. And then we'll go up here, and we can see that's 3.5 because it's in between those two values. And then that's across there. So 1 goes to 20 milliamps, 3.4 goes to 43. If I'd drawn a nice straight line, then we're ready to go. And it says the resistance when it's 4.5 is 51 milliamps. Okay, that is a unit change. Divide 1,000. Use the equation R equals V over I. So this is at I'm very rich, and we want R. So R equals V over I, 4.5, but then the bit that you need, divided by 0.051, equals 88.2 ohms. Explain why the resistance of a filament lamp changes as the voltage increases. So we've got this idea that the wire gets hot. What then happens is the positive metal ions inside the metal, here's the electrons trying to move their way through. These start vibrating more. So the positive metal ions, so temperature goes up. So the kinetic energy of the positive metal ions goes up, and this impedes electron flow. The electrons find it harder to go through because the electrons are bashing about in front of them. So resistance increases as voltage increases. As the filament heats, the positive metal ions vibrate more, and this impedes electron flow. And there we go.